Hi everyone, this is Mrs. Snowbeck. Today we are going to cover Unit 9, Lesson 4, Lateral Areas and Surface Areas of Pyramids and Cones. And right here in front of you, you can see we have a square pyramid. In fact, this is a right square pyramid because I can see that this right here has a right angle at the bottom, which means it's standing upright. And I see a lot of vocab words here. I see lateral edge, which remember, lateral edges are like these edges on the sides. And then I see base edges, which here's a base edge, here's a base edge, here's a base edge, here's a base edge. I also see vertices. I see 5 vertices, which are the corners, right? So here's a vertex, 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 vertex. But this one on the top is considered to be like the vertex. It's the spot where all the lateral faces come together. But altogether there are 5 vertices. And then one other thing that I really want to point out here, which is a new vocab word, is the slant height. So do you see how the slant height comes down from the vertex to the middle of one of the base edges? And so it's like the height of the slant. The height of the slant. The other thing that I want to do right now is practice drawing a pyramid. So let's practice drawing a square pyramid just like this. What I do is I start with 2 of the sides. So I am going to start with a V with 2 sides. I'm going to put a dot at the top, and will you guys please do this with me? That dot is going to be the vertex, and so I'm going to connect down to the other vertices. And then I'm going to dot in the other 2 sides of my square base. And then I'm going to connect up to the top. And I try to always offset that dotted line in the back so that you can see it. And that to me looks like a square pyramid. And if you wanted to make it a right square pyramid, you could add in another dotted line to show that the height there is perpendicular to the base. Here's another pyramid. You can see this one is a pentagonal pyramid because it has 1, 2, 3, 4, 5 sides. And if I unfolded this pentagonal pyramid and laid it out flat, this would be the result. So this would be the net of the pentagonal pyramid. Let's jump right into the formula for lateral area. Remember, lateral area is the area of all the sides, but it does not include the base. So lateral area for a pyramid is going to be 1/2 PL. P is the perimeter of the base. And then that cursive L stands for slant height. Why they chose a cursive L, I have no idea. Maybe it's based on a Greek word or a Latin word or something like that. But L, cursive L, is the representation for slant height. Number 1, find the lateral area of this square pyramid. So our formula is 1/2 PL. And we're just going to go through the letters and try to find each of them. So P, perimeter of the base. It says this is a square. So that means all the sides around the base are going to be the same length. So 4 times 4 would be 16 for the perimeter around the base. And if I highlighted it in red, you could see it'd be this, 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 and this. That's the perimeter around the base. Next, let's talk about slant height. The slant height is the height of the base, and it is represented here by that pink dotted line. So 6 is coming down from the vertex down the slant, perpendicular to one of the base edges, so 6 is your slant height. So lateral area is 1/2 times 16 times 6. Half of 16 is 8. 8 times 6 is 48. So this would be 48, and then it's lateral area, so it's inches squared. Number 2, find the lateral area of a regular hexagonal pyramid with base edge of 9 centimeters and slant height of 7 centimeters. Let's try to draw this. A hexagonal pyramid means the base is a hexagon. So I'm going to draw 3 sides of the hexagon. It's going to look kind of like a bowl. Go ahead and do this. Put a dot up above. connect down to each of the vertices that you see below. Now we can see 3 sides of the base, but we need to dot in the other 3 sides. So there's the hexagon on the bottom, and then I connect up to the top and up to the top. And there it is. There is our hexagonal pyramid. I love it. And it says it's a regular hexagonal pyramid with base edges 9. So this is 9 centimeters. And it says the slant height is 7. So I'm going to use a different color here. Slant height starts at the top, at the vertex, and goes perpendicular to the base. So that slant height would be 7 centimeters. Nice. Okay. So lateral area, think about your formula. Lateral area for a pyramid is 1/2 PL. P, perimeter of the base. This is a hexagon. Each side is 9. So 9 times 6, 54. Slant height, yes, given to us. It is 7. So now plug it in. 1/2 times 54 times 7. And you probably need a calculator, which is fine. You should get 189 centimeters squared. Moving on to surface areas. Now surface areas are the lateral area of the pyramid plus the area of the base. So lateral area is only the area of the sides around the object. For surface area, it's any surface you can touch on the outside, so you must include the base. So it goes like this. Surface area is 1/2 PL plus B. And remember, P stands for perimeter of base. L stands for slant height. And capital B stands for area of base. So we're going to only have to add 1 base versus when we did prisms, we had to add 2 base areas. Pyramids only have 1 base. So it's pretty much lateral area, which is 1/2 PL, and then you add the base area. Number 3. Find the surface area of a square pyramid to the nearest tenth. All right, I see surface area, I see pyramid. So our formula is 1/2 PL plus B. Let's go down the list. P. It says this is a square pyramid, so that means all sides are going to be 12. So 12 times 4, all around the bottom here, would be 48. L, slant height. Uh-oh, you can see they did not give us the slant height this time. And so do you see that red dotted triangle in there? What we're going to do is we're going to use that triangle and we're going to do Pythagorean theorem. So we're going to use this triangle right in here and we're going to do Pythagorean theorem. Now the bottom of that triangle is only halfway across the 12, or it's half of the base edge. So this distance right here will be 6 centimeters. So our triangle, if I just redrew that red triangle, this is 6, this is 16, and this is the slant height. So we're going to do 16 squared plus 6 squared equals slant height squared, which is 256 plus 36 equals slant height squared. 256 plus 36 is 292. And then you have to take the square root. So the square root of 292 is 17.09, and that is your slant height. Next we have the B, base area. Now the base is a square, it says up here, so it's going to be 12 by 12, which is 144. We have all of the numbers we need. So now let's fill it in. Surface area equals 1/2. P is 48. L is 17.09 plus 144, the base area. Grab your calculator, type all of that in. And the surface area is approximately 554.11 centimeters squared. Go ahead and check that. Pause the video, type it in, make sure you get that. All right, for number 4, I am going to have you pause the video and try this one, and when you're done, unpause the video and check your answer. So here's my work. If you need to pause the video and kind of check your numbers, please do so. Number 5, find the surface area of the regular pyramid to the nearest tenth. So surface area, pyramid. Surface area is 1/2 PL plus B. Let's go through our values. Perimeter of the base. It says it's a regular pyramid and there are 1, 2, 3, 4, 5, 6 sides. So it's a hexagon. And so we're going to have 5 times 6. Because this one side is 5 and there's 6 of them. So that's 30. Slant height is 8. We can see that with the red dotted line. Now area of the base. This is the part that's going to get tricky. So the base is a hexagon. We're going to have to do the 6 dreaded steps. Haha, so think about your hexagon, you guys. You have a hexagon, which is 6 sides. This is a side length of 5 centimeters. And we have to find the area of that thing. So here we go, 6 steps. I'm going to do a different color here to separate it. So step number 1 is you find a central angle. So we want to figure out how big is this angle. Take 360, divide by the number of sides, you get 60. So that angle is 60. Step 2, cut that in half. 60 divided by 2 is 30. Now the reason we cut that in half is right down the middle. This is 30, this is 30. And now we have 2 smaller right triangles. And once we have some right triangles, we can do SOHCAHTOA, which we might need to do. Step number 3 is find the base of the triangle. Well, the good news is the base is given to us. It is the 5. So we don't have to do SOHCAHTOA for that part. Step number 4 is we have to find the height of the triangle. Now let me make this red here. The height of the triangle is going to be this red part, this red segment. And so what we're going to have to do is a little SOHCAHTOA. And what we're going to do is only use half of our triangle. So the triangle that we'll be working with has a 30-degree angle here. We want to find the height, I'll call that H. And then instead of using 5, we have to break that up into 2.5 and 2.5. And so our triangle that we're working with is only a length down there of 2.5. Think about SOHCAHTOA. If we go across, the 2.5 is opposite. The H is adjacent to our 30-degree angle. So again, think about opposite and adjacent. And think about SOHCAHTOA. So for the height, I think opposite and adjacent are going to go with TOA. So we're going to go tangent of 30 equals 2.5 over H, height. Multiply by H. And then remember, if you have H tangent 30 equals 2.5, you're going to divide by tangent 30. Divide by tangent 30. So these cancel out, and our height, and now I'm going to have to type this in, 2.5 divided by tangent 30 should be about 4.33. Please check that on your calculator. Make sure your calculator is in degrees when you do SOHCAHTOA. Okay, so we've done steps 1 through 4. Now step 5 is to find the area of the triangle. Remember, it's base times height divided by 2 for a triangle. So for our triangle, our base, let me just circle these numbers again. Our base was 5 and our height is 4.3. So it's going to be 5 times 4.33 divided by 2. And our area is approximately 10.83. So area of the triangle is about 10.83. Finally, remember, if our triangle is looking like this green one, I'm outlining it up here, how many of those do we need to fill a hexagon? Well, we need 6 of them. So we're going to take 10.83 times 6. And when we multiply by 6, we get 64.95, approximately 64.95. And holy smokes, all that work, our base area is 64.95. We are still not done. So now we're going to get back to our equation, surface area, and we're going to plug in, I think we have all of our values, so we can plug stuff in. So surface area equals 1/2. The P is 30. The L is 8. And the base area was 64.95. Type all of that into your calculator, and the surface area turns out to be 184.95 centimeters squared. Now, if your answer is off a teeny bit, it's probably because your base area is slightly different than mine, because maybe you rounded earlier or something like that. As long as you're close to 184.95, if it's a tiny bit off, don't worry about it. Moving on to cones, let's talk about lateral area and surface area. Lateral area formula for a cone is pi r L. And again, L is your slant height. R is your radius. Lateral area is the area around the sides, but it does not include the base. Surface area is going to be pi r L plus pi r squared, because you're going to have to add in that base area, because surface area is the sides plus that circle on the bottom. Number 6, a waffle cone is 5.5 inches tall and the diameter of the base is 2.5 inches. Find the lateral area of the cone. All right, let's draw a cone here. There's a few different ways to do it. One is to just draw it like so. We wouldn't need any hidden lines because in this case we would be able to see all of them. It says the waffle cone is 5 inches tall. That is not a slant height. That's going to be the height of the cone. So right in here is 5.5 inches. And then the diameter of the base, well, that would go across here, and that diameter would be 2.5 inches. And it says find the lateral area of the cone. Lateral area is pi r L. Let's see if we can find our values. Radius. Well, if the diameter is 2.5, you're going to have to take half of that. So you get 1.25 for your radius. The slant height. We do not have the slant height. The slant height would be this distance. I'm kind of outlining it in blue. And so we're going to have to find that slant height. So think about your triangle. This is 1.25. This we know is 5.5. So our triangle looks like this: 1.25, 5.5, and this is the slant height that we need. Do a little Pythagorean theorem. 1.25 squared plus 5.5 squared equals slant height squared. I know the slant height is the C because it's across from the 90. So when I do this, 1.25 squared is 1.5625. 5.5 squared is 30.25. Add them together. And you get about 31.81 is L squared. Take the square root. And you get 5.64. 5.64 is your slant height. Haha! So we have 5.64. Do we have all of the values that we need? I think we do. So lateral area is going to be pi times r, which is 1.25, times slant height, which is 5.64. And you're going to multiply all that together, and I think you get approximately 21.99, and it's going to be inches squared. Number 7, find the surface area of a cone with diameter 14.8 and slant height 15. Surface area cone is pi RL plus pi r squared. Let's find our values. R is going to be half of the diameter, so 14.8 divided by 2 is 7.4. L is 15. Yay, they gave it to us. I think that's all we need. We have all of our values, so this one's pretty quick. It's going to go pi, R is 7.4, L is 15, plus pi, and then it's 7.4 again, squared. All right, grab your calculator, type all of that in. And if you type it in correctly, you should get about 520.73. And then remember, any kind of area is units squared, so centimeters squared. Great. Will you please pause the video? Try number 8. When you're done, unpause the video. And if you need to pause the video and check your numbers with mine, great. Go ahead and do so. Otherwise, the answer should be about 7.54. Awesome. So now would you guys try Unit 9, Practice 4? If you need help, let me know. And have a great day.